So hello students, hi again. In this class, we'll learn about binomial theorem, right? We have or we will cover two topics of binomial theorem. One is about the expansion and the general term, right? The other would be the properties of coefficients of a binomial expansion or in binomial expression, right? So let's start. So again, you know my style, right? I always start from the definition of the chapter, right? So the chapter's name is Binomial Theorem. So let's talk about binomial expression and its definition, right? Binomial expression, right? So what is binomial expression? What is the definition of this, right? We'll cover that first. So any algebraic expression which contains two dissimilar terms is called binomial expression, right? Any algebraic expression which contains two dissimilar terms is called binomial expression. Now, what do I mean by dissimilar terms? Dissimilar term means two variables or two different variables. For example, x minus y. So there are two dissimilar terms. Xy plus 1 by x. Two dissimilar terms, right? Maybe 1 by z minus 1. Two dissimilar terms. So here the variable is 1, only z, but they are dissimilar terms. Right? It is not 2 minus 1 or it is not 2z minus z, right? Two dissimilar terms. 1 upon x minus y to the power 1 by 3 minus 3, right? They are dissimilar terms. Now, what is binomial theorem? Let's come into that now. Binomial theorem, right? What is this? The formula by which any positive integral power of a binomial expression can be expanded in a form of series, right? The formula by which, go through it very carefully, by which any positive integral power, right, of a binomial expression can be expanded in the form of a series. All of you remember what is a series we talked about in the previous lectures of sequence and series. So all of you remember the definition of series, right? Is known as binomial theorem. Right? Now, let me give you an example. So if x and y are any real number and small n is any natural number, then x plus y to the power n can be written as, now very carefully look at the way I write the equation. X plus y to the power n can be written as nc0 x to the power n plus nc1 x to the power n minus 1 y to the power 1, y is introduced here, plus nc2 x to the power n minus 2 y to the power 2, right? Plus dot 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 dot. Let us take any random middle term ncr, where r lies from 1 to n, right? ncr x to the power n minus r y to the power r plus dot 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 dot. The last term is ncn y to the power n, right? This is the whole binomial, theorem, how to write it. Can be also written. Now, if you guys remember, we talked about summation in the chapter of sequence and series, right? How to write summation. So if we try to, compress this large equation into simple terminology, we can use the summation rule here. R starting from 0, oh sorry, R can we start from 0 because the first term has NC0 in it, right? R starting from 0 to N, NCR, x to the power N minus R, y to the power R, right? Now you can get back from this particular short form to this particular long form by just substituting values of R from 0 to N, right? This theorem, if you want to prove this theorem, I'll write it. This theorem can be proved by induction. What is induction? Induction is something which I'll teach you in sets chapter, right? Induction, sets or relation chapter, right? Now there are some observations, right? Observations or points to be noted, right? First point, the number of terms in the expansion. In the expansion. Can all of you guys guess? Please pause the video and try to guess how many number of terms are there in this equation, right? So if we count 0, 1, 2, dot, all the way to n. So from 1 to n, there are n terms, right? But we have to also consider this first term, NC0. So there are in the total of n plus 1 terms, is n plus 1 terms, right? Second one, second observation, which is, that is one more than the number of indices, right? Indices. So total, what is indices? Indices is this particular number n. It is n plus 1, that is 1 more than n. If it is x plus y to the power 3, the number of terms would be 3 plus 1, 4. If it is x plus y to the power 100, the number of terms would be 100 plus 1, 101, right? That is 1 more than the indice. The sum of the indices. Indice is nothing but the power. The sum of the indices of x and y in each term is nothing but n. If you notice here, it is x to the power n, y to the power 0. So n plus 0 is n. X to the power n minus 1, y to the power 1. N minus 1 plus 1 is again n. X to the power n minus 2, y to the power 2. N minus 2 plus 2 is again n. The sum of powers of x and y would be always be n, right? The third thing, the binomial coefficient of the terms equidistant, right, from the beginning and the end are equal, right? So hence we can write, because all of you know the formula, right? NC0 equals to NCN minus 0, which is NCN, right? Which is the last term and the first term, right? They're equal, right? Okay, now let's move to the next formula. Next observation. Symbol NCR can be also denoted as NR, right? Or CN comma R or ANR. These are nothing but different type of ways to denote NCR, right? Now there are some important expansions which we won't talk about now. You can anyway write personally, text or message me in Urban Pro. There we can have a detailed lecture of this, chapter. Now we'll jump back to the general term, right? The general term, right? So what is a general term? General term in binomial expansion, right? The general term. The general term is also known as the, very important notice, r plus one term, not rth term, r plus one term in the expansion of x plus y to the power n is given by nothing but tr plus 1, because it is r plus 1 term. Tr plus 1 equals to ncr x to the power n minus r y to the power r, right? So if I give you a question, right, find the coefficient of x to the power 7 in the expansion of ax squared plus 1 by bx to the power 11. Please pause the video and try it on your own. I'll solve it right now, right? Now let's find the general term. So in the expansion of this, what will be the general term? A general term would be nothing but tr plus 1 equals to ncr. What is n here? N is 11. So 11 cr x to the power n minus r. What is x here? X is here nothing but ax squared. So ax squared to the power n minus r, right? I will write 11 minus r multiplied by y to the power r. So 1 by bx to the power r. We'll solve it. It's nothing but 11 cr a to the power 11 minus r over b to the power r. I have separated the ab term with the x term. What will be the power of x? It will be 22 minus 3r, right? Now we know that we have to find the coefficient of x to the power 7. So here we have x to the power 22 minus 3r. If we equate 22 minus 3r equals to 7, we should get the value of r from here, and we can substitute it in the coefficient term to get the coefficient of it, right? Now, here from this equation, if we substitute 7, it is nothing but 3r is equals to 15. So r is equals to 5 from this equation. Let's substitute. It will be tr plus 1, that is t5 plus 1 equals to 11c5 ax squared to the power 6 1 by bx to the power 5. Am I right? Right? Any doubt here? So what is the equation? What is the answer? 11c5 a to the power 6 over b to the power 5 into x to the power 7. Right? Now, therefore, the coefficient of x to the power 7 in the equation. What was the equation? The equation was ax squared plus 1 by bx to the power 11. It was 11, right? Yeah, 11 is 11c5, right? This is a coefficient because these are variables. Coefficient is this. Okay, I hope you got the concept of general term. Now we'll move to the concept of, or the topic of the second part of the chapter, that is properties of binomial coefficient. Thank you so much for now for the first part. See you soon in the next part.